Welcome, Dr. Narayanan. We're so grateful that you could spend some time with us this afternoon. Tell us a little bit, for our listeners about who you are and what it is that you're doing in relation to space up there in the panhandle of Florida.
Certainly. First of all, thank you so much for the invitation. It's really an honor to join you all today and to share a bit about myself. I'm Dr. Narayanan. I'm a first-generation academic, a research professor here at Florida State, studying the effects of what happens when we travel into space, but also how along those research studies and that journey into space, we learn a lot about ourselves in addition to our investigation of the universe in a way that benefits life here on Earth in many ways.
Yeah, no, that makes sense because, a lot of times people, when they just think about space, certainly, like even me, before I came to know Kevin and the work that the students were doing, you just assume that the only job related to space is like an astronaut. But then you realize there's so many connections, beyond the career opportunities that are available in space, but also, like you're saying, those applications. So tell us a little bit about the research. What do we know that's happening with the astronauts as they're heading out on their space travels?
Certainly, and I appreciate that sentiment. I was a kid, I also dreamt about being an astronaut and really admired their objective as a representative of all of us traveling into space, and also in particular the space industry as a whole. I think as a perfect example of really a community and industry that all disciplines, all backgrounds can get involved with, and that's what I encourage and foster through my own research, where the focus is in space and clinical medicine, though it's also an example of bridging together diverse backgrounds and expertise to understand from different perspectives what happens when we travel in space. Our adaptations in space are unique in the context of medical conditions where our entire bodies are affected by the space environment, which is different from, say, a medical condition that's generally affects a specific element of biology. So in turn, to truly understand what happens in space, I have myself an interdisciplinary background. I've had the opportunity through our space program to study science, technology, engineering, mathematics, and combine my own set of creativity to combine those disciplines but also understand the significant element of non-STEAM disciplines in context of communication, in the context of management, in the context of designing these experiments and financing for them. And that's similarly with regards to the students involved that are not just students interested in medicine or engineering, but interested in education, interested in finance, and really the ones that are driving the success of these really unique opportunities and experiences.
That's outstanding. I want to share with our listeners, I met you because you volunteered to be a part of a statewide advocacy effort to call on Congress through the American Institute of Aeronautics and Astronautics through our Congressional Visits Day. So the moment we met, the overlap of interests, right? Your STEM and outreach interests, we're a really good fit. So our listeners will only learn in the future how many good projects that we're already working on together.
No, he's been really talking you up to I think you met recently with the group. Didn't he come recently to one of the Wolfpack meetings?
Yes.
So like the kids already are talking about the possibility of working with you in the future.
I get a couple emails. I get kids now every week that are saying, I want to do the internship, so I need to know what are the details. Yeah. So that's something we'll talk about. I want to go back to the research. So we study the human condition in space many ways. So I'll just mention 3 terms and I'll let you elaborate on them, because I know if we understand how the human body works in space, we can better develop countermeasures or pharmaceutical or pharmacological efforts to help counter what space is doing to us. But I'll just mention in vitro models and animal models and then human models. And maybe you could tell us a little bit about those 3 in the context of maybe some of the work that you've been a part of.
Perfect. Thank you for those examples, and great examples that describe the diversity and scope of science projects, where science is from my perspective, an approach and utilizing the tools that are currently available, but could be made available in the future through in vitro models or design of organism research or research that we can do with people. The aim in all those areas in any context is really to set up observations, ask questions about these observations, and then acquire data to see if the questions that we ask match and fit with the observations, or if they don't. And it's really the intent of the data, the information, that helps us make those decisions. So those three examples are all examples of being able to explore different kinds of worlds, so to speak, in terms of observations from different perspectives, where people are biologically incredibly complicated and intricate and unique biological machines, where there are a lot of millions and billions of different events taking place every second, and continues to. It's humbling from my perspective. But
well, I mean, we always hear about the study of the twins, right? Like that's the most famous medical research that an average layperson like myself would know. Is it more than just the effects of gravity on the bodies in space that becomes a concern?
Thank you, Shauna. Yes. So the space environment provides us a way to study biology in general, and with people, with individuals, or in any of in the examples that Kevin mentioned, based off the unique environments that only exist in space. They are not capable of being reproduced entirely, even through simulations here on Earth. Gravity is a significant factor. And the example I like to give is how, generally speaking, all organisms living on Earth will always experience gravity. There really should be no context where organisms should not experience gravity, since life evolved here on Earth. Though our spaceflight project sets up an environment where gravity no longer exists as we know it here on Earth, though biologically very naturally adapts and continues to thrive. So it's amazing how biology has intrinsic capacity to adapt to gravity changes, but then also the various adaptations, environmental factors that are included in space, including a unique type of radiation, being in a remote, distant environment, being in an isolated environment, and additionally, all the environmental factors that affect things such as microorganisms, different ways of how air is circulated, different ways of how we observe our environment. Those have all have an effect that, in a way, I think space provides us unique perspective and a reminder. And then additionally, going back to the different model systems in terms of in vitro, in terms of model organisms, in terms of human research, those are all also different perspectives of studying these environmental factors in very precise ways to allow us to test very specific conditions. With human research, there's millions and billions of different conditions taking place all at once. But of course, that's how human biology works. But then there are limitations in terms of kind of interpretation, kind of studies that we can do that model organisms open us to study more specific manner and allow us to capture more specific information. And then similarly with in vitro models, those are all ways to very simply control for and reduce the complexity of people, of a human condition, but then learn from that and then interpret back to human physiology.
Right. I think of the space station, now that it's been up for 20 years, as a very unique And even though it's man-made, it's a biome, right? It's like a microbiome. So not only do we need to understand how each kind of life form functions differently, but then you got to consider how they interact with one another. So I think there's so much fascinating opportunity if we're going to be a species that lives for a long time in space at any one given time. We have to build an entire ecosystem, or at least understand, hopefully, how the organisms relate. What are your thoughts on that?
Absolutely. From my perspective, central to all functioning ecosystems at any level, from Earth itself being a planetary ecosystem, all the way down to the microorganism level, central to all those is communication. Communication of information, communication of material, communication of biological elements, and ecosystems are very exquisitely designed to control and adapt and move information, whether it's biological, whether it's chemical, whether it's technological, whether it's how we communicate with each other, in very precise and sophisticated ways. And if they're not allowed to happen, then communication breaks down, and then there are side effects from that. And I think our projects in space are a fantastic example of being able to test communication, but also everything that's contained within an ecosystem. And Kevin, you're absolutely right. The International Space Station is an ecosystem in itself. It's an ecosystem that is not cannot be replicated in its entirety on Earth, here on Earth. But because it's different, we can utilize the knowledge of it being different and what we learn from the differences in the same way we test observations and hypotheses, and whether our data, our information that we are communicated to based off our experiments match the hypotheses, or if they don't, we utilize that information and make discoveries and acquire new knowledge that that benefits everyone on this planet.
Awesome. Now, you started in West Virginia. You've gone through, you went to school some in Texas, I know, and of your past, when you were a student or a graduate student working on your PhD, which space project really got you the most excited? What specific thing did you say, this is worth getting up early? Was it mice? Was it a cell study? What space-related research when you were younger really fired you up?
That is thank you so much for that question. Yes, you're right. I've had quite a journey. I'm actually an immigrant to West Virginia. I grew up in Morgantown. I was actually born in Germany. My family as well. I have half my family is from northern part of India, and the other part is from southern India. When growing up in West Virginia, I was blessed to grow up 30 minutes away from a NASA center. And because of that proximity, and also the connection West Virginia has through Homer Hickam, through Chuck Yeager, through Katherine Johnson, and many more individuals, it was the human connection that inspired my thought process with our human space exploration projects. I grew up at a time when the International Space Station was being thought about, designed, built, and launched. And similarly to the human connection, what inspired me with the International Space Station was that, one, it was an international space station. A great example of how through our human space exploration projects, by working together, we can do incredible things. By collaborating and through that also discover new things along the way, with the ISS being science lab, the first ever in history in space. So all that really captured my admiration of NASA. And being a first generation academic, being from a family where we didn't talk about NASA, we didn't, we're not familiar with professions in, as a doctor and engineer. What I admired about NASA was that didn't really matter. It was my passion, it was my enthusiasm, it was my interest. And related with that, the opportunity to design, calculate, and contribute to NASA's project constellation as a high school student, that was living the dream. So for me, that moment of itself was everything I ever aspired to.
What did that entail? Did you have to go out there and look up at the stars and like kind of share out the information? I mean, what was that project that was so inspiring for you?
That project was one, I had the opportunity to be present at NASA Katherine Johnson Independent Verification and Validation Facility and get to interact and converse and meet with all these individuals across the NASA Center and across the NASA community. We were doing virtual meetings even back then when I was in high school, and seeing how many individuals were involved with the Ares 1X project as part of now with Space On System. That was inspiring, and then also looking at previous missions and reviewing reports and learning about the technicalities and looking at and meeting with all the NASA community and seeing how many different layers were related with this project, but then being able to study that before even taking really high school or a physics class,
right?
But being enabled to be in an environment to be very curious, to learn and ask a lot of questions, and that way learn how to program and apply this information in a way that I could apply my interests and design this program, and then in a small way contribute to the human space exploration program. Was fascinating. Then also the decision making, which which exemplified my interest of being now a professor. How through the support of mentors, through the support of the community, through support of the space program, supported my the opportunities I had to contribute, but then also to be involved with this team project and build or design a rocket together. But to get to the point of my interest in space medicine, that was really hearing from astronauts at the time and hearing from their experiences and being communicated how their experience in space was life-changing. They talked about the overview effect. They talked about how that psychological experience of looking at the Earth from space changed their perspective, and that caught my interest and it got me thinking. Well, if astronauts are describing these effects, what actually happens?
Sure. Let us jump in because we're both
Yeah.
smiling because of something you said.
Well, we both want to comment on it.
Yeah, and I'll throw out a comment that does not require any additional follow-up, but then she'll quickly follow.
Wait, what if it's my comment? Okay.
I want to talk about, for our listeners, we are big fans of what you just described as a tipping point that was based on not talking about space or learning about space, but it was interacting with people in the field that you wanted to be in.
That's exactly what I was going to say.
It's
I was talking about the idea of the experiences versus like just learning.
So we're gonna dovetail off your last narrative, and we're gonna once again remind our audience, we believe the best STEM education is by doing and being a part of. And if you want to be an engineer, you need to work with engineers. If you want to be a scientist, you need to work with scientists.
Well, I just think that's what's wrong educationally, right? Like when I think, I mean, I've been a teacher for a long time, and I know it's more of an English and debate teacher versus science. However, I just know from being in the classroom, we just don't do those experiential kind of learning the way we should. We're not really connecting outside of the classroom. So it's really exciting to see that was what you experienced and it led it on. I want to pivot a little bit too to talk about the work that you do outside the community to get others who might not otherwise have that opportunity to become interested in space. And I know that you work on a lot of different committees, and that's one of your passions. Can you share with us a little bit about why you care so much about getting others kind of involved in this effort?
Certainly. Well, one thing I learned, it's how I first discovered opportunities in the space program, and through education outreach and learning about how many different ways there are to get involved in space. And from my experience, if those opportunities, events did not happen, then my engagement and involvement with our human space exploration program would be very, very different. And I am very, very grateful for the fact that I grew up 30 minutes away from a NASA center. And I wonder if I had not, then my early involvement with NASA would have been maybe very different. But now we are in a time where opportunities are much more accessible, and in the context of NASA and many other STEAM and non-STEAM disciplines. So the access to get involved with different careers is absolutely fantastic, and to learn and be able to identify at an earlier age, is this a topic I'm interested in? Is this a topic I'm passionate in? Is this a topic I'm dedicated to spend a lot of time and effort into really applying myself to contribute in a meaningful and professional way? And that's my motivation as well for being involved with any professional organization, highlighting how there are. One thing I learned throughout my doctoral journey is that I started with a few questions, but and I anticipated answering a whole lot, which perhaps I did, but I think I ended up with 10 times more questions at the end of my doctoral experience. And those are really the opportunity for more students to get involved, and next generation to really answer the many more questions that are left unanswered.
Very good. I'm so excited that not only do we have a few more years of the ISS, but NASA is actively looking for something they call CDFFs, Commercial Destination Free Flyers. In other words, replacement space stations, or the commercial space station. So do you see yourself having some payloads on those, on the ISS and in the remaining years, and the new orbital platforms?
Thank you for that question. I've been blessed with the opportunity. I've had the opportunity to be a lead and be involved with ISS payloads already, and these have been phenomenal experiences. I would love the privilege and opportunity to expand upon ISS and be involved with the commercial industry in terms of STEAM development. And but more importantly would be for me to also include next generation of students and young professionals that have a similar passion, similar motivation, similar interest to expand our understanding of our universe, and also hope to enable us to return to the moon together.
Excellent. Yes, and we're coming up close on our time. I want to throw out one more question, then I'll turn it over to my colleague.
Don't forget the internships.
We want to discuss the importance and our upcoming ideas. We are wrestling with ideas and how to give kids more internships. Would you like to share anything about that from your perspective and how we might get some of these very excited middle and high school students into labs such as yours at Florida State?
Yes, thanks for the question. And I hope there's enough time because there's certainly a number and many opportunities to get involved with NASA, whether at the centers, whether at academic institutions, whether at now commercial and government and in industry. I wish I were a kid or a college student again, because there's so many more ways and diverse ways to get involved with our space industry than ever before, I think. We are at a very unique time in our human space exploration efforts where it's absolutely fascinating. And the first suggestion I would offer to any student, young professional is to reach out and ask questions, be curious, reach out to anyone, don't be shy, don't be hesitant. And learn about all the different opportunities and programs out there, because there's hundreds of them. And there are NASA has a specific portal for internships called NASA OSSI. There are every academic university in the country has likely a few professors or scientists that are conducting NASA-related research. And what I did was identify who those individuals were and communicate, reach out to them and ask, would you be open to having me be involved in some capacity? Or there are professors that will have specific calls, inquiries for students. If you're interested in these type of projects, there are many, many ways to get involved, both STEAM and non-STEAM. And just a few examples. There are also conferences, whether local, whether state, whether national. And for me, it was a challenge at times to, and that's also how I identified with the space medicine community, through conferences. But there are also resources available at K through 12 or in particular collegiate levels that provide support for students to go to conferences and similarly go around, ask questions, talk to people, and eventually anyone will be able to identify a program opportunity that is specific to your interests and hopefully also connected to supporting our human space exploration projects.
And I know that you and Kevin are working on one there where you are, where maybe some of our students can head up. That's exciting. Well, you actually took, our last question is always about advice. And that just sounds like you hit the nail on the head there. And I really appreciate the idea that it's about what you said about asking more questions at the end of your journey versus when you began. And I think that that's really a good way for everyone to think about the fact that if you feel like you know everything, that's not really learning. It's at the end of that journey when you still have more questions to either research or pass on to others that the real excitement of education begins. Thank you so much for spending some time with us today again. And we really appreciate that. And we look forward to more work with you in the future.
Likewise, Shauna, Kevin, and thank you for the opportunity. It was a great meeting with you today.
Thank you so much, Doc.